All right, last page of section 1 in chapter 11 on statistics and organizing your data for display. Another good way to do is a stem and leaf plot. And stem and leaf displays show the distribution of data while preserving the individual values. So if you are making a grouped frequency distribution, you're totaling up your different numbers and you have no idea what the number is anymore because you've grouped it into a class. This way, with a small amount of data, you can do things like a stem and leaf. If you have grouped, it's usually because you have a lot of data to do and you don't really need to see, any one point's not going to do much for you. But a stem and leaf is good for fewer number of data points. And let's look at this one here. This is a stem and leaf plot, I call them. There's always a key that is trying to tell you what things mean. So right here where there's a 6 and a 4, this is the stem. These are the leaves off the stem. And 64, 6 line 4 means a 64. So that must have been the minimum value was 64. And there was a 65, a 67, a 71. So it only shows the data points. It doesn't fill in what's missing. Okay, these are the actual data points. When you get towards the end, this is 111, 113, and then the maximum number must have been 125. Okay, so notice that the stem always goes in order. Okay, make sure you start where your minimum number starts and you end with room to put your maximum value. Okay, so let's see, sample size. Let's see, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. If I count all of these, apparently I'm going to get 27. That's how many data points I had on my clipboard. Okay. The minimum value is 64. The maximum value is 125. Any gaps or extreme points, as in outliers? I don't know that there's any big gaps. There's no 68, 69, 70. Nothing that really stands out. It's pretty uniform, although this looks a little thin in here. And maybe this 125 seems to be quite a ways away from everything. So we'll be doing something that will help us calculate, how far is really far for an outlier to be mathematically. But right now, this 125 is twice as much as this is. And there doesn't seem to be a whole lot of 100 and somethings. So this could be an outlier. Okay. So you're going to need to make these. So to construct a stem and leaf, what you need to do first is cut each data value into leading digits, or the stems, and the trailing digits, which is the leaves. Number the vertical stem starting with the lowest minimum, going to the highest maximum, skipping no values. Whether you have a data point or not, the stem, whether you have a data point or not, you need to put these in order. Okay, from beginning to end. Then you're using 1 digit or 2 digits, and to have an ordered stem and leaf plot, these numbers, the leaves, have to be in order. Okay, that would be the preferable way. I've seen people make an unordered one first and then go back and order the numbers that they have. That sometimes is easier. And then you must have a key that you're putting in there. Okay, so let's do this one here. The following data represents the ages of people attending a political rally. Construct a stem and leaf display. Let's see, 1, 2, 3, 4, 5. Apparently there are 20 numbers here in my data, and we need to find the maximum. They're clearly not ordered, so it looks like most of them are 2 digits. 58 is the maximum and the minimum 17. All right. So it says we need to cut the values with the leading stems. So apparently I need a 1 to a 5. So 1, 2, 3, 4, 5 is my stem. Make a line. And then you can put the data in. I think I'll make an unordered one first. So that's a 29 because I don't want to lose anything. 45, 19, 35, 22, 20, oops, 7, 25, 37. Try to keep your columns in the leaves straight as you can. I'll make a better one when I do that. Wait, I crossed this one out. Did I put it in? 26, 58, 18, 21, 31, 32, 24, 39, 21, again, 44, and 17. All right, so that's my unordered plot. Let's do an ordered, can't spell, ordered plot. All right, still 1, 2, 3, 4, 5. I'll try to be a little neater with this. All right, so there's only these, so 7, 8, 9. Okay, this one has 2 1s. Try to line them up. A 2, a 4, a 5, a 6, a 7, and a 9. Okay, this one had a 1, a 2, a 5, a 7, and a 9. I'm trying to line them up here as I draw them. This one had a 4, a 5, and an 8. Remember, these stems are all in order with no skips. The data, though, is whatever the data is. Okay, what do you have? And that's an 8. Okay, and when you do it that way, you can visually see, if you space these right, that this stem of 2 or 21, that has the most data in it. Okay, and then they're like comparable. Okay, so you could do a frequency count. You could say that 1, 2, 3, 4, 5, 6, 7, 8. 8 out of the n of 20. So n equals 8 equals 20. Okay, 8 out of 20 is about 40% of the attendees for the political rally. Attending rally were in their 20s. Okay. 11 out of 20, or approximately 55%, were under 30. 1, or around 5%, was over 50. So these are things that are, this is a visual display of your data. A descriptive statistic are these percentages that we're using this data to come up with these numbers. That was the actual find. Okay, so if I was trying to like get more people to the rally, maybe we're not hitting older voters, would be an inferential statistic I could get from that. If we wanted to bring them in, or we want to concentrate on the fact that we're liked by the younger voters, there's all kinds of inferential, but these are your descriptive statistics from this. Okay.